Good morning, viewers. Today I am going to discuss about the electronic concept of oxidation and reduction, as well as the concept of oxidizing and reducing reagent, and the concept of redox reactions. Now, according to this electronic concept of your oxidation and reduction, just look into the next slide. We can start discussion about the electronic concept. Just consider here. According to the electronic concept of oxidation, we can find that oxidation is a process that involves the loss of one or more electrons by an atom or a molecule or an ion, and simultaneously in this process we can say there will be an increase in the oxidation number, and due to this process of loss of one or more electrons, there will be the increase in the positive charge as well as a decrease in the negative charge on the species. It may be the formation of a positive charge ion, or it may be the formation of a molecule from negative charge ion. Simultaneously, we can say that there will be an increase in the oxidation number. Now, whenever we consider the concept of this oxidation, then we can find that just a minute. According to the concept of this oxidation, we can find that the process involves the loss of one or more electrons, and simultaneously here we can get the concept of this one. Just look at this: loss of one or more electrons, and the species which can lose the electrons may be an atom or molecule or an ion. And simultaneously here I have given some of the examples. Here in case of these 4 examples, we can find that these are certain atoms which can produce the positive charge ions by the loss of one or more electrons. So when sodium loses one electron, we can get the formation of Na+, and when magnesium loses 2 electrons, it forms magnesium ion Mg+2. When aluminium loses 3 electrons, it produces Al+3 aluminium ion. Similarly, this one is stannous ion, and iron can produce the ferrous iron with the loss of 2 electrons, and ferrous iron can lose 1 electron to produce the ferric iron, and like that we can get a positive ion, stannous ion, can produce the stannic ion by the loss of 2 electrons. And ultimately, in case of the negative charge ion, here the chloride ion produces the chlorine molecule with the loss of 2 electrons, and here the hydrogen molecule produces H+ ions with the loss of 2 electrons. And in all these processes we can find it may be an atom, it may be an ion, or it may be a molecule which can produce the species by the loss of one or more electron, as a result of which there is an increase in the positive charge or decrease in the negative charge. Similarly, you consider the electronic concept of reduction. According to the concept of this electronic concept of this reduction, we can find that reduction is a process that involves the gain of one or more electrons. Just look at this: gain of one or more electrons by an atom, or it may be a molecule, or it may be an ion. So we can consider here reduction involves the decrease in oxidation number and results in the increase in the negative charge or decrease in the positive charge. Here you can consider some examples related to this reduction process. In case of this, we can find chlorine molecule accepts 2 electrons or gains 2 electrons to produce the chloride ion, and iodine gains 2 electrons to produce iodide ion. Similarly, hydrogen ion H+ ion accepts 2 electrons to produce H2, And ferrous ion can be formed by the ferric iron by the acceptance of one electron. Similarly, ferrous iron can produce your Fe or iron atom by the gain of two electrons. Similarly, cupric ion produces copper by the gain of two electrons. So these are some of the examples related to your reduction processes. And whenever we consider the reducing power, generally we can find that the reducing power generally increases down the group in the periodic table, and the reducing power generally decreases, and oxidizing power or oxidizing character increases along the period from left to the right in the periodic table. And simultaneously, these are the two concepts that oxidation involves the loss of electrons, whereas reduction involves the gain of one or more electrons. So from the concept of this oxidation and reduction, we can also come across with two other concepts. That one is the concept of oxidizing reagent and the reducing reagent. Now, if we consider oxidation and reduction as well as the concept of oxidizing reagent and reducing reagent, we can find that these are the concepts related to the redox reaction. And basically, this redox reaction is a particular concept which is involved in the formation of different electrochemical cells or electrolytic cells, or it may be completely involved in the process of your metallic corrosion. That is why I can consider that this concept of oxidation reduction as well as the concept of oxidizing and reducing reagent is a fundamental concept which is to be confirmed or clarified in terms of these reactions, whatever I'm going to show you in this particular part of the lecture. And here we can consider that the first one is your oxidizing reagent, and we can find that oxidizing reagents are those which itself undergo reduction but have the tendency to oxidize others. मतलब जो दूसरे रिएजेंट्स को, दूसरे सब्सटेंस को ऑक्सीडाइज करते हैं, उनको ऑक्सीडाइजिंग रिएजेंट्स बोलते हैं, और जो दूसरों को ऑक्सीडाइज करते हैं देन साइमल्टेनियसली वो खुद रिडक्शन होते हैं. That is why we can find that oxidizing reagents are those reagents which itself undergo reduction, but they have the tendency to oxidize others. Thus, we can find that these reagents have the tendency to gain one or more electrons since they themselves undergo reduction. That is why, because of the reduction process, we can say that they will have the tendency to gain one or more electrons. So whenever we need to determine the equivalent weight of these oxidizing reagents, you can look into this. We can determine that one in terms of the ratio between the molecular mass of the oxidizing reagent to that of your total number of electrons gained per molecule by these oxidizing reagents. And some common examples of your oxidizing reagents are potassium permanganate, KMnO4, potassium dichromate, K2Cr2O7, different halogen molecules like chlorine, bromine, iodine, then hydrogen peroxide, H2O2, nitric acid. All these can be considered as your oxidizing reagents. That means they themselves undergo reduction and they have a tendency to oxidize others. Similarly, when we consider the reducing reagents, we can find reducing reagents are those which itself undergo oxidation but have the tendency to reduce others. Thus, we can find that these reagents have the tendency to lose one or more electrons, and simultaneously we can determine their equivalent weight or equivalent weight of the reducing reagents from the number of electrons they lose per molecule. So here we can find the equivalent weight of a reducing reagent is equal to that of the ratio between the molecular mass of the reducing reagent to that of your total number of electrons lost for the molecule. So here, if we consider some of the common examples of these reducing reagents is sodium thiosulfate, Na2H2O3, sodium oxalate, oxalic acid, that is H2C2O4, oxalic acid, Na2C2O4, that one is your sodium oxalate, hydrogen peroxide, that one is your H2O2. Similarly, different halogen acids like HF, HCl, HBr, HI, and iodides like potassium iodide, FeSO4, SnCl2, all these can be considered as the reducing reagents. And just look into this. Here I am giving you some of the ionization processes of different oxidizing reagents or common oxidizing reagents. For example, whenever we consider potassium permanganate in acidic medium, that one produces Mn plus 2 upon ionization in acidic medium. That one is converted from MnO4 minus to Mn plus 2. In MnO4 minus, we can find that the oxidation state of manganese is +7, but in case of Mn plus 2, it is +2. So there is a 5-unit change in the oxidation state, and in this process, this MnO4 minus ion is accepting 5 electrons, as a result of which we can find that the equivalent weight will be the molecular mass of the KMnO4, which is 158, divided by the number of electrons gained, which is equivalent to that of your 31.6. Similarly, in an alkaline medium, potassium permanganate is converted into potassium manganate. That means MnO4 minus is converted into MnO4 2 minus, and simultaneously this process involves the gain of 1 electron. That is why the equivalent weight of KMnO4 in alkaline medium is 158 divided by 1, that is equal to 158. Similarly, in neutral medium, we can find that MnO4 minus is converted into MnO2. That means permanganate ion is converted into manganese dioxide, and this particular change includes your change in 3 units in the oxidation number of your manganese. That is why here there will be the involvement of 3 different electrons, and here we can find that the equivalent weight is equal to 158 by 3, which is 52.6. Likewise, the other examples we can consider here. In case of potassium dichromate, there is the involvement of 6 electrons. That is why it is divided by 6, as a result of which we can find in acidic medium the equivalent weight of K2Cr2O7 is 49. Similarly, hydrogen peroxide can be converted into water in acidic medium, as a result of which we can say that there will be the gaining of 2 electrons. Here we can also consider that fluorine molecule accepts 2 electrons to produce 2F minus, fluorine molecule produces 2Cl minus, iodine produces 2I minus. That is why we can consider all these are the oxidizing reagents, since they itself undergo the process of reduction. That is why these have the tendency to oxidize others, and they have also the tendency to reduce themselves. Similarly, in case of nitric acid, we can find that depending on the concentration of the solution, this nitric acid can be converted into different molecules. In concentrated form, this nitrate ion can be converted into nitrogen dioxide, which involves there is a change in 1 unit in the oxidation state. That is why this process involves 1 electron, absorption of 1 electron. Similarly, in case of moderate concentrated solution, we can find that NO3 minus is changed into NO or nitric oxide, and this process involves 3 unit change in the oxidation state. That is why we can say that there will be the absorption of 3 electrons. Similarly, in the diluted concentration, this nitrate ion can be converted into nitrous oxide, or it may be ammonium ion, which involves 8 electrons, and simultaneously this process involves your reduction process. Similarly, you can find the ionization of certain reducing reagents. Here, in case of FeSO4, the Fe plus 2 ion can be converted into Fe plus 3. Similarly, with the loss of 1 electron, then tin can be converted into stannous ion with the loss of 2 electrons. And likewise, you can consider some other cases also. Here you can find that in this case, these ions, just consider in HF, HCl, HI and Ki, we can say that there will be the formation of different species with a loss of certain number of electrons. And in case of sodium oxalate, we can say that oxalate ion can produce carbon dioxide with the loss of 2 electrons. Then thiosulfate ion can produce tetrathionate ion with the loss of 2 electrons. Similarly, hydrogen peroxide in case of this produces oxygen along with the formation of H plus and loss of 2 electrons, and which represents the reducing character of hydrogen peroxide. So these are some of the reactions representing the action of your reducing agents. Then you can consider the concept of redox reaction. Now, whenever we consider the redox reaction, this word redox includes two different terms. One is reduction, the other one is oxidation. So any particular reaction that involves the simultaneous occurrence of oxidation and reduction reactions are considered as your redox reactions. So we can find that in case of this redox reaction, both oxidizing and reducing reagents are taking part in the reaction, and oxidizing reagents undergo the reduction while reducing reagents undergo the oxidation process due to the presence of each other. And these are some of the examples which involve your redox reaction. And in all these cases, we can find that please look into this. In the first case, stannous chloride is converted into stannic chloride, which includes the increase in the oxidation state of tin. That is why here we can consider that this tin undergo oxidation. That is why we can say that this one is a reducing reagent. Whereas in case of FeCl3, that one is converted into FeCl2, in which ferric iron is converted into ferrous iron. That process involves your reduction. That is why we can say that FeCl3 is an oxidizing reagent. Likewise, we can consider in case of this sodium thiosulfate is a reducing reagent, whereas iodine is an oxidizing reagent. In all these reactions, next further, we can find KMnO4 is your oxidizing reagent, and these reagents are your reducing reagents. Similarly, in case of this, sodium oxalate is reducing reagent and potassium dichromate is oxidizing reagent. And in all these three reactions, we can find that K2Cr2O7 is oxidizing, whereas the presence of your sodium oxalate, FeSO4 and HCl, all these are the reducing reagents. So these are some of the common reactions which you can consider. Now you can look into some of the ionic equations representing the redox reaction. So here in the first case already I have told that stannous ion in case of SnCl2 is converted into stannic ion. So this process involves the oxidation, since this one involves the loss of 2 electrons. Similarly, in case of the second one, ferric iron is converted into ferrous iron. And this process also, in order to balance the electrons, since in case of redox reaction, there will be no formation of electron at the end of the reaction. We have to balance the reactions in terms of electrons. So here we need to multiply 2 with the second equation so that the number of electrons involved will be balanced. So finally, overall, we can get this type of equation. Similarly, in case of this also, we can find in the conversion of thiosulfate ion to tetrathionate ion, there will be the loss of 2 electrons. And in case of iodine 2, we converted into your iodide ion. We can find the conversion involves the absorption of or gaining of 2 electrons. That is why overall the reaction becomes like this. So these are some of the cases which include both simultaneous oxidation and reduction. And here we can assume that due to the oxidation reaction shown by stannous ion, there will be the occurrence of your reduction reaction shown by your ferric iron in the first case. In the second case, the oxidation reaction shown by your thiosulfate ion forces the reduction of your iodine to produce iodide ion. Then in the next two reactions, here we can find the balanced equation related to, or balanced ionic equation related to the reaction between potassium permanganate, sodium oxalate, and in the presence of your sulfuric acid, as a result of which we can consider here MnO4 minus in acidic medium can be converted into Mn plus 2 with the gain of 5 electrons. Similarly, here we can find in sodium oxalate, there is the presence of oxalate ion which can be converted into carbon dioxide with the release of 2 electrons. So as already I have told, in case of this redox reaction, there will be no final formation of your electrons or gain or loss of electrons. So simultaneously we have to balance the electron. That is why the first equation is multiplied with 2 and the second equation is multiplied with 5. As a result of which we can get the final equation in this form. It will be 2MnO4 minus plus 5C2O4 2 minus plus 16H plus gives rise to 2Mn plus 2 plus 10CO2 plus 8H2O. Then simultaneously in the last case, in the last reaction also we can find here KMnO4 generally acts as your oxidizing reagent, FeSO4 acts as a reducing reagent, whereas sulfuric acid acts as your acidic medium. And in acidic medium, same reaction of MnO4 minus 1 minus ion will be repeated. And here also we can consider the absorption of 5 electrons. Similarly, the ferrous iron present in FeSO4, that one is converted into ferric iron, and with the loss of 1 electron, and in order to balance the equation we need to multiply 10 with the second and 2 with the first one, so that the number of species will be same in both the sides. So this one is the balanced equation, and simultaneously from here we can find that due to the reduction reaction oxidation takes place, and due to the oxidation reaction also reduction takes place. That is why we can say that redox reaction is that type of reaction which includes the occurrence of simultaneous oxidation and reduction reaction. So this is all about your oxidation process, reduction process, oxidizing reagent, reducing reagent, and the concept of redox reaction. So my dear viewers, if you like uh, my video in my YouTube channel, please like the video. Please, if you are the newcomer to my channel, please subscribe my channel, and also click on the bell icon so that you can get the latest update of my videos or lecture videos. And with that, I wish that you people will like my video, and as a result of which it will encourage me to upload different videos from time to time. Thank you very much. Have a nice day.